So we're going to look at the following example. Determine the open intervals on which the graph of f of x, which is going to be e to the negative x squared over 2, that's all in the exponent, is concave, upward, or downward. So the first thing we're going to do is take our function, it's given to us there, and we're going to start by finding the first derivative. You got to use the chain rule. E to the negative x squared over 2 times the derivative of the power. So it'll be a negative x, which I'm just going to write in the front. So negative x e to the negative x squared over 2. And because we're talking about concavity, I actually need the second derivative, not the first one. So we're going to have to take another derivative. So now we've got to use the product rule because we have two terms being multiplied. So copy the first one down, negative x. The derivative of e to the negative x squared over 2 was negative x e to the negative x squared over 2. The derivative of negative x is a negative 1. So if you notice, your derivative has, both of your terms have an e to the negative x squared over 2 in them. So I'm going to factor it out. You'll be left with an x squared minus 1. And I want to know, this function is always defined, so I just want to know, when is it equal to 0? Well, e to a power is always positive. It's never 0. So the only way I'm going to get 0 is from the second part here, x squared minus 1. You can factor that as x minus 1, x plus 1. So I get two solutions, 1 and negative 1. So I'm going to make a sign chart here as well. Draw my number line, and I'm going to mark it with those numbers, so negative 1 and 1. And I'm going to pick test points, so pick negative 2, number between negative 1 and 1, 0, bigger than 1, 2. But now you need to plug them into the second derivative and determine the sign. So if I look at my second derivative, this is e. Let's plug in negative 2. This will be e. And if negative 2 squared would be 4, but it'll negative 4 over 2, negative 2. And then it'll be 4 minus 1. This is positive times a positive, so it's positive. If I plug in 0, e to the 0 is just 1. So here it'll be positive times a negative, negative. And finally, f double prime of 2, you'll still have e to the negative second, 4 minus 1. Positive times positive is positive. So anywhere where there was a positive, my graph is concave up. Anywhere where there's a negative, my graph is concave down. Okay, so concave up. What are the intervals? It's negative infinity to negative 1 and 1 to infinity. It's concave down on the interval negative 1 to 1. And there's where my graph is concave up, and there's where my graph is concave down.